to tell you some format stuff. So this whole time we have been doing derivatives. We have been doing this and I haven't been telling you. So let's just take something like this for an example. So this is what we have been doing and you just don't know we've been doing it. We have been doing a derivative like this. We're going to derive this y variable with respect to x. Don't write this down, don't worry about it, but I'm going to explain it. This is what we've been doing. We derive the variable y with respect to x. So we're changing y with respect to changing x. Then we did this, 15x squared. And when I did that, I derived the variable x with respect to x. Okay, so every time I derived the variable I was doing with respect to x. So here I derived this y with respect to x, and here I derived this x with respect to x. This is really 1. That's why we haven't been writing it. This, we've been secretly shortcutting and writing that. Okay? Does that make sense? We've been doing it the whole time. I just didn't want to overwhelm you. But that's what we have been doing. Okay. So implicit differentiation means we're going to derive with x's and y's all mixed up together. Because before, we were only deriving with y equals. So y isolated. So let's see what happens here. Okay. I'm not going to do this. I'm just going to do straight to implicit. Okay, so ready? We're going to derive. So I'm going to derive this unit. So this is going to be 2x. Okay? Do you want, we can write this now, but you don't have to. I derived that variable with respect to x. Okay, next I'm going to derive this, so it'd be 2y, and I derived that variable with respect to x. And then I'm going to derive 25, which becomes 0. Okay, I will never write that. Instead of this, I would just write 2x, right? Because I don't need dx dx. And instead of this fancy thing, I'm going to abbreviate it with a y prime. Okay, so this line is the official, what you're doing, but I'm not going to write it like that. I'm just going to shortcut it like that. Okay, now what you're going to do is you're trying to isolate y prime. So I'm going to subtract 2x. And then I'm going to divide by 2y. And there's your equation. Okay. You know me, I like to connect things here for you visually. You're going to learn how to graph this in your advanced math course. So in the second half, you're going to learn how to graph this. It's a circle with a center of 0, 0, and a radius of 5. Okay, so that's what that graph is. So right here would be the coordinate 5, 0. The slope will be negative x divided by the y. That's what the formula says, negative x divided by the y. What is a divide by 0 answer? What do you say when you have a divide by 0? Undefined, right? What is the slope of this tangent line? Undefined, right? It's an infinite slope. Okay, what about on your graph right here? You would have a coordinate 0, 5. So the slope is negative x divided by the y, which is 0. What is the slope of this tangent line? 0. Right here, you would have the coordinate negative 4, negative 3. That coordinate would be on that circle. This would be the slope of that tangent line. Let's plug it in. The slope is negative x, so that would end up being positive 4 over negative 3. Does that make sense? A slope of negative 1.333, that would be your slope. Okay, so that's what's going on. You're creating an equation that will give you the slope. All right, here we go. Ready? X cubed becomes 3x squared. I differentiated that with respect to x, so I don't worry. The next is 12y cubed, but that was a differentiating a y, so I need to attach a y prime. Next, we have a y cubed, so that's 3y squared, but we differentiated a y, so we attach a y prime. And then when we derive 5, that's a 0. Okay, now I want you to remember when we did our log stuff, we always were trying to collect x terms like that. So I'm going to leave all my y prime on one side. And I'm going to move the non-y prime stuff. Okay, now I'm going to GCF a y prime out. We did this exact same algebra with our log unit. And then I'm going to divide. Okay, so there's your slope equation. Okay, last example. Ready? X squared becomes 2x. Good, done. Y cubed becomes 3y squared, but we derived a y, so we got to attach. Okay, now this is the part that we'll run into some problems here. 4x squared y squared. We're going to have to treat it like a product. So this is what I'm going to group together. Okay, I'm going to think about that as the product of two things. Okay, you ready? Derive this, keep that. Derive that, keep that. Derive that and keep that. Good? Plus, keep that, derive this, which is 2y, but as soon as you derive something with a y, y prime. Okay, does that make sense with the product? We're good with it? I derived that times kept that. I didn't need a y prime on it, right? I didn't need a y prime because I didn't derive any y stuff. Here I needed a y prime because that's what I did. And then the derivative of 6 is 0. Okay, these two units I'm keeping because they have y primes in them. So 3y squared y prime. And I'm going to simplify this. I'm going to put the 4 and the 2 together. So 8x squared y prime. So then I moved this and I moved this. Okay? Now I would GCF this out. I'm sure you guys are probably already shortcutting this. Okay? That's it.